This video is going to look at section 5.5, which is the law of sines. What we need to use the law of sines for is when we have a non-right triangle. So when we know the lengths of two sides and the included angle, we know that it forms a unique triangle. Think back to your geometry. That was our side angle side that we used to figure it out. Well, we can use this to find the area of a triangle using only those two sides and the included angle. Let me show you how. So let's imagine here's our triangle, and here's our triangles. Obviously we've got angle A and the side A is across from it, angle B and side B is across from that, angle C and side C is across from that. So we know that if we were to draw in our altitude of our triangle here, we'd get a right triangle, and we can work with right triangles because it uses our sine, cosine, tangent functions that we're used to. So for example, if I was to label this height of the triangle h, I could say that the area of this triangle is 1/2 base times height. But of course, we don't have the base and the height, so we can't find the area that way. But we do know that if I look at my right triangle, the smaller right triangle here, we could say that the sine of angle C is equal to the ratio of h over A. And again, this is because we drew in the right triangle. So if I solve for h is basically saying it's going to be A times sine of C. So if we plug in A times sine of C for the h into our equation, then we have an equation that says that 1/2 our base times A sine of C would be the area of our triangle. And that's what gives us our area formula, given just two sides and the included angle. So 1/2 AB sine of C. You'll see your area formula on your cheat sheet. It's on the back side there with the law of sines and cosines. And your book uses this K to represent the area of the triangle. Note that obviously depending on the size and the angle that you know, your formula is going to be basically the same thing but plugging in different values. So in other words, your area of a triangle is going to be 1/2 one side times the other side times the sine of the included angle. And again, these formulas are going to be given to you, so you don't need to memorize them. So if I want to find the area of any non-right triangle, if I have two sides and the angle included between them, I can easily find them using our area formula. Now, how do we find missing sides and angles of triangles that are not right triangles? Well, that's where our law of sines comes into play. We talk about that these triangles that are not right triangles, we call them oblique. And of course, there's two types. If you remember from geometry, you've got your acute and obtuse triangles. So let's think about how to figure this out by using what we just talked about with the area of the triangle. Remember that we could find the area of our triangle using multiple ways, just depending on which two sides and angle we have. So we know that all three obviously are going to be equivalent because the area is equivalent. So let's manipulate this formula that we have to work with. If I divide everything by 1/2 all three sides, A, B, and C, I end up with something that looks like this, which we know we can simplify, and it basically gives us this, that sine of C over side C equals sine of angle A over side A, which equals the sine of angle B over side B. And this, in essence, is our law of sines. So our law of sines is basically what we said. We have our angle, and it's the sine of that angle over the side that corresponds with it. So we're going to look at an example. But before we go on any further, we need to remember a couple things, because law of sines is good, but for certain problems, it's going to be a little bit more complicated, and there is a possibility of having more than one solution. This first video is going to look at the ones that only have one solution. But remember that when we think about our triangles, when we were to find the sine of an angle, the sine of an angle is always going to be equal to the sine of its supplement. So for example, if you think of sine of 120 degrees, well, if you think of your unit circle, the sine of 120 degrees is going to equal to the sine of 60 degrees because they have the same reference triangle. And of course, we know in the first and second quadrant, sines are both positive. So remember that as we move on further, especially when we get to the part in the second video that talks about two solutions possible. So let's actually work through an example. We want to start with knowing two angles and a side of a triangle. So here's our given situation. We know we've got side A, side C, angle A, angle C, and side A. And we want to find the missing sides and angles. When you know two angles, it's pretty easy to find the third angle. What do you have to do? Well, you know that all three angles in a triangle sum to 180 degrees. So if I tell you angle A and C, find angle B is not that hard. Angle B is going to basically be 105.5. So let's plug in what we know into our law of sines. We know that if I look at angle A, which is 31.6, the sine of that angle over the side, 10.4, is going to equal the sine of angle B, 105.5, over side B, and is equal to the side of angle C, 42.9 degrees, over C. I should have degree symbols on here, but I think that got cut off whenever I was doing my problem here. So how do we find these last two sides? Well, we've got three things that are equal. We really don't need to look at all three at the same time. So let's take a look at part of these. Let's take a look at the one that we know something about, the angle and the side, and maybe look at part that we're missing a side. So what we're going to do is we're going to kind of ignore this for right now and use this equation to help us define side B. What are we going to do? Well, we cross multiply and solve for B. So when I cross multiply and then I plug into my calculator, of course making sure that I'm in degree mode, I can find my angle, or excuse me, my side of B is approximately 19.13. We can do the same thing to find side C. Again, ignore the middle. Let's take something we knew from the beginning and cross multiply and solve for C. When we cross multiply and solve and plug into our calculator, we get that C is approximately 13.51. So our final answer is, we know all three angles and we know all three sides. So how do I find the area of the triangle? Well, we've got more information than we need to know for here, but we do know that it's not a right triangle, so you really could use any one of the three formulas that we have to find our area of our triangle. So pick one and see what you get. You should find out that your area of a triangle is about 67.7. And of course, since we don't know the units, we just say units squared. All right, now it's your turn. Go ahead and pause this video and try this example. See if you can use the information you have to find the missing sides and angle. When you're done, unpause the video and I'll show you the solution. Here's our final answer. And if I ask you to find the area, again, you can pick any one of the equations and you should get approximately 1.78 units or so. And that's it. That's how you can use your law of sines when you have a unique solution.